This video is going to show you how to do all the problems. Keep in mind there's many opportunities, different ways to solve something, so you might do it differently than I do. So I'm just going to change things to decimals and multiply through at the same time. So I'm going to say 3/5 x. I know 3/5 is 0.6, and then 3/5 times 4/3 gives me 12/15, and I know that really 3 goes into 12 4 times, 3 goes into 15 5 times, 4/5 is 8/10. So for me, I feel like that's faster than multiplying by anything else, and I end up with 1.04. So now it's a straight up two-step equation, minus 0.8. These cancel, 0.6 x equals. Now you could have also multiplied through by a number to clear your decimals, but I feel like because I have a calculator, I'm not too bugged by this. So I could divide by 0.6, and I end up with 0.4 as my solution. So that is choice 2. Right here, you could have said, I don't want to have decimals, so I'll multiply through by 100th, or by 100, or by a 10, and get rid of your decimals. Let's look at the next. So the area of the rectangle. So first thing I always do when I see that, I draw a rectangle is represented by the whole thing. So I remind myself, oh, area equals length times width. When area is length times width, I know I'm looking at something I need to factor. So I've got 3x squared minus 10x minus 8. I know it's going to go into two binomials. I know the only way to make 3 is 3 and 1. That's nice. I know how to make x squared is x and x. Notice that does not help us at all. They all have that 3 and 1 and x and x. Consider the ways to make 8. You have 4 and 2. It's done for you because it's multiple choice. Your only choices are where to put them and positive or negative. So remember, you're trying to get a negative 10 in the middle. So if you do your 4 here, that is going to give you a 12. So keep in mind you want that to be negative because you know you need a negative 10 in the middle, so you would do your 2 here. So I could FOIL this out to check. I'll do that in red. So I end up with 3x times 1x is 3x squared. 3x times negative 4 is minus 12x plus 2x minus 8. So I can see that that's going to work. 3x squared minus 10x minus 8. And I just need to see which choice that is now. So 3x plus 2 and x minus 4 is choice 1. When I do a multiple choice, I actually try to ignore the solutions. They can overwhelm me. I just do the problem first. You can do it whatever way makes sense for you. Okay, so our next problem, Brittany's solving this quadratic. Her first step is shown. So her first step, and then the original problem, it says what two properties did she use? So we need to know what those properties mean. I can tell right away that she has distributed this. So she definitely did the distributive property. And then it looks to me like she has reordered this. So instead of minus 8, minus 10x, so we're looking at our commutative property. So first, decide what properties she actually used. Notice they said she used 2, and now go back and look at your solutions. Okay, so this one, C is 2a squared minus 5. D is 3 minus a. So they want C minus 2 times D. Well, C is 2a squared minus 5. D is 3 minus a, so minus 2 times D. So D is 3 minus a, so we'd put that down there, 3 minus a. So now we have a, I don't want to say simple, but it's just a combining like terms problem. So 2a squared minus 5. Don't forget to distribute your negative. That's the biggest mistake people make. So minus 6, and then this is really a minus 1, so you're really looking at negative 2 times negative 1a, so that turns to plus 2a. Now I look for my like terms. 2a squared has nobody that is like it. My 2a has nobody that's like it, so plus 2a, and now my negative 5 and my negative 6 turn into negative 11. So go up there and take a look. You know it's not these two, and you know it's not this one, so it has to be choice 3. Oh, all right, which equation has the same solution as this? So let's solve this. X squared plus 8x minus 33 equals 0. What they're really saying is complete the square. So your brain wants to think complete the square. If you flake out on that and don't remember how to complete the square, you can check and see which ones work. We can talk about that too. So you have x squared plus 8x. Move your 33 to the other side. And then you start to complete the square. The reason I say that is because they've done it this way. So we take our x squared plus 8x, we leave a spot, take half the middle term, square it, so we get plus 16 on this side equals 33. Now this is interesting. When you have it moved to the other side, when you've added 16 on this side, you also have to add 16 on that side. So this one would turn into x plus 4 squared, half of that middle term is what we square, equals 49. So that would be choice 1. If you're uncertain, you can solve these equations. It will just take longer. Which pair of equations would have negative 1, 2 as a solution? We will circle back to this. I'm going to send you to a video for this one and show you how to do it that way, because you can do this with solving with your calculator. So this would be TI Inspire as far as the most efficient way. For the purposes of knowing whether you got it right, it is choice 3, but you're going to look to the video and the Inspire. So let's continue onward. The formula for electrical power. Remember, we don't really care where the formula came from. We don't need to memorize the formula. We just need to know we're solving this for I. And they make that easy with the multiple choices. So I'm just going to say P equals I squared R. I like to isolate my variable, and that lets me know that's what I'm solving for. So I squared R, this is multiplied. So we would divide both sides by R. So when I do that, I end up with P over R equals I squared. If you're in the business of crossing things off right now, you can say immediately it's not going to be choice 3 or 4. And now you just want to remember that the opposite of anything squared is the square root. So now you're going to take the square root of both sides. This will cancel out, and that's going to leave you with I equals the square root of P over R. So our choice is 2. All right, in this one we are solving using substitution, and they're asking us what equivalent equation could he use. So here we have y plus 3x equals negative 4. Our first step of substitution would be to get y by itself, so we'll move the 3x to the other side and get a negative 3x minus 4. Substitution means we're going to take that value of y and plug it in for y here in the other equation. So we'll have 2x minus 3y is negative 3x minus 4 equals negative 21. Now I'm going to look and see which of those it matches, and it clearly matches number 3. Our next problem, solve algebraically for this. The one thing you want to remember is you only flip this sign when you multiply or divide by a negative. Notice here it is a 2-point question. That means that it's not multiple choice. We need to see your steps. So you have your opportunity to subtract on both sides or add, and actually let's talk about that. Which one should we do? We should move our x's to the right as far as moving and avoiding negatives. So minus 1.02x minus 1.02x is going to simplify out with positive numbers. Either way will work, but you have your 1.04 minus 1.02, and you end up with 0.02, so plus 0.02x. Now you'll subtract 2,000 from both sides, and you'll end up with 0.02x, and you've got your 3,600 minus 2,000, and you end up with 1,600. You're dividing both sides by a positive number. Whoops, divide by a positive number, so you do not flip this. So you end up with x, and you're dividing by 0.02. So you end up with 80,000. You could turn this around and make the mirror image. So if you flip it, you would say x is greater than 80,000. Either way, you're going to get credit if you have it correctly written. If you had done it the other way, you would have come up with a negative number and you would just need to flip the inequality. Solve for this algebraically. So what are they really asking? Again, 2-point question. You can't just plug it into a calculator. You're looking for ZPP. You could do the quadratic. Those are your things. You're trying to think, okay, does this factor? Or I could also solve with the square root equation approach. So I'm going to first go for ZPP and think, can I factor this? So I have x squared minus 8x minus 9 equals 0. I know x squared is x and x. I know you can make 9 with a 9 and a 1. And I need those to add to negative 8. So a negative 9 plus 1 is going to give me negative 8. So I would say, okay, x minus 9, x plus 1. And then I'll FOIL to just check it out. So x times x would give me x squared. X times 1 would give me 1x. Negative 9 times x would be negative 9x. And then minus 9. That is going to look nice for me, so I know that I have got this correct. Now I do the ZPP. So remember, ZPP is saying one of these has to be 0 if the whole thing is 0. So x minus 9 equals 0, or x plus 1 equals 0. You could do your little branches. This is a one-step equation. You can do it in your head, or you can write it out. And then x equals negative 1. Explain the first step you use to solve the given equation. So I would just say I factored the quadratic. And then you could say to use zero product property to solve. All right, let's move on. So determine algebraically. So this is another way of saying, hey, you gotta find this without your calculator. You can't just graph it. You can check it with your graph. So keep in mind you can check with graph. You can even use the graph as an assist if you have trouble with factoring. However, the thing that should jump out to you is you need a GCF. I see 3 x's in the first one, I see 2 x's, and then I see 1 x. So let me model that. So f of x equals 3x cubed plus 21x squared plus 36x. My right out of this would be 3 times x times x times x plus 21 times x plus 36 times x, just as a starting point. Now I could further take this down and say 21 is 3 times 7 and 36 is 3 times 12. I'll do that and I'll just kind of cross that off. Just so you can see, okay, so we're looking for what do they all have in common. I can take out a 3 and an x. I can take out a 3 and an x. I can take out a 3 and an x. They all share those things. So now I remove that. That's my GCF, leaving me with x squared plus 7x, that's what's left, plus 12. Remember, it said determine the zeros. That means, hey, set this guy equal to 0 and solve. So now I need to factor. So you have 3x, and then you've got your x squared plus 7x plus 12. So x and x. Think of ways to make 12 that also add up to 7. So immediately 3 and 4 jump out to me. They need to be positive, equals 0. I'm not even going to FOIL that to check. I'm so confident, but I would suggest on a Regents exam that you do. And you now know it's a ZPP. 3x has to be 0, or x plus 3 has to be 0, or x plus 4 has to be 0. The hard part here is not the actual solving of the equation, it's recognizing it. So you subtract 4 from both sides, so x could be negative 4. X could be negative 3, and x could be 0. Any of those will give you an answer of 0 when you plug in, because with the zero product, at least one has to be 0 to give you an answer of 0. This one, Marilyn collects old dolls. She purchases a doll for $450. Research shows this doll's value will increase by 2.5% a year. Write an equation that determines the value after t years of purchase. So this is what we're working on right now that I said would be easier when you went through this week's material. So we know that we are looking at the AB to the x. So you've got your v, well, your function f of x equals AB to the x power. Remember we said that B you could remember as a growth or a decay. It increases by 2.5%. So keep in mind that increase, it starts as 100% or 1. It increases by 2.5%. 2.5% is really so it's 0.025. So 1 plus 0.025. So there is your B value. So you know in this case they're saying the value, so your value of the doll is your starting value A, 450, plus your increase of percent, 1.025, or you could write that out as 1 plus 0.025, and it says T years of purchase, so instead of writing an X, we'll put a T. That's your general equation. Now, assuming the doll's rate of appreciation, that means growth, will the doll's value be doubled in 20 years? Okay, so this just means you're going to plug in a 20 for t and decide, does it double? Does it get to 900? So value equals 450 times your 1.025 to 20. That's a calculator problem, and you end up with $737. 737.38. Okay, there's a couple things here. You know you're talking about dollars and cents, so that's an automatic, definitely round it to 2 decimal places thing, and your answer clearly is no. So you do have to take a minute to write that down. No, it will not double. Okay, justify your reasoning. It is not 900. 900 will be double. Let's erase that. 900 would be double. Okay, let's look at our next one. So this is also a really nice calculator problem, and we will see a calculator to support this, but let's at least write the equation here. This is a 4-point question. Okay, so the first thing you're going to need to do is actually write the inequality. So they've given you the variables. So they say X is the matinee tickets, Y represents the evening tickets. So matinee tickets are $7.50 each. So you would say, okay, $7.50 for my matinee tickets, and evening tickets are $12.50. And that is Y, and it says she has $100. So it says write an inequality, so that's our key. She could spend up to what she has, so she could spend $100 and that would be equal, but she could also spend less than that. So we're looking at that inequality. So that is our first step, is write that inequality. Our second step is to graph that inequality and then answer the question. So couple of things to be reminded of. They did not give us a set of axes that tells us what we have to count by, so we can keep that blank for the moment. And they did not require that we graph this by hand. They have no way to check that, so we could graph it on our calculator. So I am going to say, let's go ahead and get it into a form that makes sense for us. So you would solve for your y variable. So I'm just going to say, okay, so minus 750 on both sides, minus 750x, sorry, and this will cancel. You'll have your 1250y is less than or equal to negative 7.5x plus 100. That's the mx plus b approach. Now you will divide both sides by your 1250, so I'll have 750 divided by 1250, and I'm going to end up with 0.6 negative, so I'll divide both sides by 1250. So I'll end up with y is less than or equal. I don't need to flip the inequality. I didn't divide by a negative, and I'll end up with negative 0.6x, and then I'll do 100 divided by 12.50. That would be 8 plus 8. Okay, well, this is nice. I immediately have my y-intercept. So I know I'm going to go ahead and count by ones. My y-intercept, my b is 8. So 1, 2, 3, 4. I do not need to show my axes if I'm counting by ones, but I'm going to do that just to play it safe here. So 5, 6, 7, 8, also for counting. And then my x-intercept, there's a couple ways I could go about this. I could jump to a calculator at this point, or I could go back to that original equation. And what I know about an x-intercept is that at that time, my y value is going to be 0. So if my y value is 0, I'll just do this in red. I would be plugging in a 0 for this y. So 1250 times 0 is 0. So just put it off here in red. So 750 x, that zeroes out, is going to be less than or equal to 100. So if I divide 100 by 750, I'm going to come up with 13 1/3. So I'll divide this. I'll end up with x is less than or equal to 13.3 repeating. So I'll just do that, right? So I know 5, 6, 7, 8, 9, 10, 11, 12, 13. I'm going to be right about here. And I can come up with all those points then from a graph or from plugging in, whatever I would like to do. I could do a table. So I've got negative 0.6x plus 8. So you could do your table and you could say, well, I need to check the 1 value, the 2 value, etc. So you've got your x and your y. So if I know I'm looking for 1, 2, 3, 4, all the way up, I don't have to include every point, but I can include some points. Like, for example, 5 times 0.6 gives me 3, well, negative 3 plus 8. So I end up with 5 and 5, just including some perfect spots on there. 2, 3, 4, 5. And then another perfect spot would be 10 and 2, just to give me enough points to do the line like this. Now, because it's less than or equal to, I get a solid line. And it says less than or equal to, so you're going to shade this on the down below it. It says, what's the maximum number of matinee tickets she could buy? So you're looking for the bottom axis says matinee tickets. She can't buy more than 13 because that's going to hit her max. That intercept is 13.3. So the most she can buy is 13 tickets. We'll walk through this on the calculator too. You'll see the TI Inspire. If you choose to do it on the calculator, you do need to copy it onto the graph, just like you have here. You can use the table feature. This can all be graphed for you, including the inequality. So we'll see that separately.